Okay, we're going to try it again for 2017 CAT class. Can we make a video or not? Will the computer allow us? By the way, we got a nice little thing here. Every time you see my pen, winner, 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 chicken dinner, win, win, win. So try to concentrate through that. Okay, shh. Now, you're a bum. If you didn't watch the movie over the weekend, did you? Not the movie that, the good movies that go out in the theaters. The 5-3 to 5-4 day one video. But I am gonna, and I probably do this on the video back in the day. I gave you ways that you have to memorize this, like cosines. Look at the same, they start the same. Cosine, cosine, sine, sine. Didn't the guy on the video from years ago say this? Like ways to memorize. And didn't the guy in the video say, you are going to have to memorize this one time. I do have this in our next quiz. I expect through just doing your homework correctly that you can remember these 6 things, in addition to remembering the ones from 5-1, page 200. Didn't the guy in the video say that? Yes, for those that actually watched it, which hopefully it is everyone, but if I compare you to my other discrete classes, did you know I did a video of an example that was going to be on a quiz? And at that point, I had 115 students. And it was a fresh video, so I got to see the hits. How many people? Do you know how many people watched that video? Take a guess. Well, you guys are giving away low, but it was like 30 something the first time. Putrid. When I told them that this 2.5 minute video was going to be a question on the quiz, then I yelled at them and I said, okay, you still have a chance to watch this video, and it's going to be a test question a week later. Go back and watch this video. Do you know what the total ended up being? Well, you're giving them that. It was like 60 something, still barely over 50%. So it wasn't that bad. All right, shows me that something's going on there. And I hope the same didn't happen to you, is why I bring this up. Because you're your own worst enemy if you did not watch those. And it was like 26 minutes long. That all you had to do was look at it in lieu of what's going to be a lengthier lesson today. Then notice how the sine one works. Win-win. Sine, cosine, sine, cosine. Then the guy, that taught you that video from years back, look at this. Sine, sines are the same, right? Ooh, someone yelled that out. That proves that you listened. Whereas cosine, it's not. It's only sine that is true. Winning. Okay, now, to memorize this one for one little quiz. It's just one little can you do it, because you do your homework on a daily basis. Notice the tans are very similar. And it's almost like SOAP. What's SOAP stand for? Same, opposite, and then always positive. That's for factoring a difference or sum of cubes. But I could use it for this. Same, opposite, right? Same, opposite. Winning, if you get this memorized. All right, then notice the patterns are the same. I can't help you on the patterns further from that. Then I thought maybe, okay, fine, we'll do this one more time. I can't really think of another one. I think I can. Let's do a different one than what was on the video, although I think at the end of the video I did do this. So what's the point of these, and where do they come from? I don't think I've ever derived them. I don't know if I know how. All right, so we accept this as truth, as this is what this is true about trigonometry. When you add or subtract 2 different angle measures, then the sine and the cosine and tangent has this little formula pattern, and you're going to have to accept that and move on. But then what you have to do in these questions is come up with sums of 2 angles that are from your special angle categories. And what are those? 30, 45, 60. And I'm going to do this maybe a little bit different than if I did do this one online, because it was on the notes. It doesn't have to be 60 plus 45, right? It could be cosine of 135. How do I get 105 from that? What do I have to do to that? Minus 30. Now, I can't get rid of that win, by the way, if anyone's looking online. This is the little crinkle that the computer's giving me this hour. We're just happy it's working. So we'll see if it, finishes off for us. Okay, now remember, cosine, what's the pattern for cosine? It goes what? cosine. Then what's next? No, I need another thing. It's either sine or cosine. What is it? It's cosine, cosine. And then what do we know about the sine? It's plus. It's the opposite because only sine formulas, the signs are the same. And those that were in honors, you did these, a lot. Okay, and then I do have to kind of go fast on this. And what you have to do fast on this one, did I do this one on the video, but I did 1645? Okay, so that's fine. It doesn't matter. But what you got to be aware of is 135 is out here, and sometimes you cannot avoid that. 135 is what kind of angle measure? 45, right? So you got to remember, what's the matter? Oh, no. All right. So 45 in quadrant 2 means this is negative 1, 1 and root 2. And then 30 is just a 30. 30, winning. 1, root 3, 2. And then you access those triangles to do the sine and cosine of these individual parts. No, you do not write the word cosine next to this ratio. The cosine of 135 is, what is the cosine of 135? Negative root 2 over 2. And anyone that puts the word cosine in front of this, you are telling me you don't understand the relationships. That is a mathematical syntaxical error that I will mark you wrong so quick your head will be spinning. Okay? Ah! What's the cosine of 30? Over 2. And then plus, what's the sine of 135? A root 2 over 2. And then what's the sine of 30? Okay, so then you can multiply these. These become negative root, not 5, root 6 over 4 plus root 2 over 4. Or you could write it as one fraction, which I'm not doing again. Okay? But you can write root 2 minus root 6 all over 4. And no, you can't subtract these. Those roots, they're like x and y. They are not like terms like radicals. Then just to make sure, if you didn't watch the video to understand these, because working in a tutoring room with a CAT student of a different class, and I know students have tough times reading these. What does this mirror? Which one does this mirror of our formulas that we had up here? The sine, and the sine difference one. So it mirrors sine A cosine B minus, I don't like writing it, I like writing it sine B cosine A, because it just keeps me in order, but I did write it, but the way I said it, cosine A, I know. Did I say B or A? I said A. Wow. It's going to get worse as I get older. Which equals sine A minus B. So who's A, who's B? Sine is, or A is 40, B is 160, and what this ends up being is sine of, believe it or not, negative 120. And then real quick to do that, that's actually a chapter 2 question now. So it was a reversal of like the way you're thinking about these. And then once you reverse the process and put it in this format, then it becomes one you can do by hand. Because negative 120 is in what quadrant? What quadrant's negative 120? Third. Because you go, and we are going to have these quite a bit throughout the, chapter 6. We're going to have to go back to these anyway. So it's good to review these from chapters 2 and 3. Even though we did look at them when we graphed, we talked a little bit about this. But side opposite 60 is root 3. Side opposite 30 is 1. Side opposite 90 is 2. And remember, they're both negative because they're in quadrant 3. So the answer is negative 1/2, right? Right. Again, this is a review of what you already saw over the weekend. What did I do? It's root 3 over 2. I wasn't done yet. Right. Just seeing if you were paying attention. Did I do this one online? Yeah. You cannot change it to degrees. Blah. Because I don't want you to. So what was it that equals pi over 12? Now I am doing this because I do need to go over radicals with you. Okay, so it was, you can start over again?
3 pi over 12. It was 7 pi over 12, the one you did on the
Good. So I did something different. Yeah. Okay, I did the other one. I did this one later. Okay. But what did we say? Someone said 3 pi over 12 and? Well, but it's only pi over 12. So if it was 3 pi over 12, what would have to be the other one? And this one does work because what you got to make sure is these end up being an over what, or an over what? 4, 3, or 6. You're in tune with what's going on here. So this is tan of pi over 4, right? Minus tan pi over 6, not minus tan of pi over 6. Okay, so then here's how the formula works. It goes like this. And we're going to loop it around there, even though identities we should never snake. Ooh, that was a little behind. That was weird. Okay, so the formula says, okay, I need the tan of pi over 4. Sign? What's the sign, plus or minus? Minus! It's the same on the top. Sorry for yelling. Tan of pi over 6 over 1. What's the sign? Plus tan pi over 4 times tan pi over 6. Winning. All right. Now I know you honor students, and actually those, I guess, that would go on to calculus next year. We should know these, I guess, before we have to, or without having to write a triangle. So what's the tan of pi over 4? 1. If you put the word tan in front of that and put 1 there, I'm marking you wrong. The tan of pi over 4 is 1. Now what's the tan of pi over 6? It is root 3 over 3. Here's 30. Opposite side of 30 is 1. Opposite side of 60 is root 3. Tan is y over x. What's 1 over root 3? Root 3 over 3. And then that's all you need. Now all you got to do is stick those here. Now this is what the guy online, that was probably the pre-Common Core guy. Probably much lighter voice and much happier about. Anyway, let's move on. Because if it was from 2013, it was before I was forced to teach. Let's move on. Move on, Mr. S. Jeez. Okay, this is what he said. He said, all right, I have a fraction within a fraction problem. So I took care of that first by multiplying top and bottom by what? Let's see if you watched the video. 3. Correct. And you distribute that, and when you hit this by 3, that becomes... What's root 3 over 3 times 3? Root 3. Winning. And then what's this? Okay, now I'm doing this because 1 times root 3 over 3 is just root 3 over 3. So that's easy. And I get 3 again when I distribute. And then the other one. Come on, you should know that. Now, I have to rationalize. So what does it mean I have to multiply this by? Which I might change colors. It's conjugate, which is what? But I also have to do whatever I do to the bottom, I have to do to the... That's so that this is a form of 1. The green, not that set of parentheses I put around that, but the green over green equals 1. So all I did is multiply this by a form of 1. This is rationalization. And down at the bottom, you should understand that when I take this times this, the middle term's going to what? Cancel out. So all I care about is those two. What's 3 times 3? 9. What's root 3 times negative root 3? Minus a free 3. One more time, I did not do this and this because those will end up being opposites of each other that cancel. It's the whole point of having a conjugate. So why waste that time? Up at the top, though, we do have a problem. 3 times 3 is 9. This is negative 3 root 3. This is negative 3 root 3. That's negative 6 root 3. Those do not cancel. And then the last one, just because of space here, I'm going to go up here. Negative times a negative is a positive. And what's root 3 times root 3? 3. And then moving along, this is 12 minus 6 root 3 over 6. And by the way, is 6 over 5 equal to 2, which I have on my board over here? Is it? Does 6 over 5 equal 2? No. So can I take just this 12 and cancel with that 6? If 6 over 5 equals 2, then yes, you can do that. But it doesn't! So what do you got to do? You actually kind of have to think about factoring out a 6 out of the top. But really, 6 goes into both of these. You know, I don't know, but I guess I should do it by factoring a 6 out. Then this is 2 minus root 3. And then now that the 6 is free as a factor, I can go ahead and cancel those. And this is just 1. 1 times this over 1 is just 2 minus root 3. Okay, so again, a reiteration of what you should have already known from your notes. This is, for those that weren't taking notes because you looked at the video, this can be considered the beginning of our notes for today. I did do 3 of these where the directions were write each function as an expression involving functions of theta. But I didn't do this one. This is a new one. I'm doing this as a bridge into today. A bridge. So what's the, what do I have for a cosine of a difference? So what do I have here, first of all? What do I start with? Cosine. Cosine who? And then what do I do next? Times. It's cosine, cosine. Good. Then what's the sine? Ooh. It's plus. Because cosine, the signs are opposite. Because signs are the same. Sine, sine. Sine, everywhere is sine. Do this, don't do that. Can't you read the sign? You guys don't know that song? Are you okay? What's the cosine of 90? Well, 90 is up here, and that's what coordinate? And then r is 1. So what's the cosine of 90? 0. This is not figure outable. That's why we're putting it in terms of a function of theta, I mean. Plus, what's the sine of 90? 1. Then this ends up being, what's 0 times cosine? What's 1 times sine? So believe it or not, this is equal to sine of theta, which is one of our cofunction identities, which we already tested you on. You've already had these. We've already seen them. You've already tested on those. Do you remember those? Okay, so what I did is I derived one of them. And actually those things that we had on our notes, those three examples where we did something similar, you could kind of call those identities, but no one would really remember them. This is a popular one, so that's why this one gets its own little situation there. So you've already taken these down. Check your notes from the past, those that take a good notebook. It's either in chapter 2 or 3 that we already did these. Why am I repeating these? I don't know. We've already done this. So if what's the tan of 25 equal to? The cotan of who? 90 minus 25, which is what? 65. I got no time for this. All right, and then, okay, this one's a little different. So what's this one? $90 minus 1 negative 30. 90 minus negative 30 is 120. Got it? And then what do you do for, okay, there's that answer. All right, this one's a little tricky, though. And I think this was the same exact example we had back in the day. Is it? It's actually tan, because what's true is tan of 24 equals the cotan of 66. But the way they wrote this is they snuck you to stick a tan in there because they used 2 properties in one. Do you remember that one from back in the day? No? Do you remember this one? Okay. Okay, this one's in radians. Secant, cosecant. So what's the same as 90 degrees in radians? What? Yeah, that's exactly what I wanted to say. Pi over 2. So this is secant. Oop, almost made that. This is equal to pi over 2 minus 3 pi over 4. That's what's true. 90 minus theta. Cosecant of theta equals secant of 90 minus theta. Right? I see that face. This is the same as 90 degrees in radians. So, multiply by 2. 2 minus 3 is negative 1. So it's the secant of negative pi over 4. That's what cosecant is equal to. Cosecant of 3 pi over 4 is equal to pi over 2 minus. We got to get used to radians and remember these things. And then one last thing. How do I solve this one? I know I'm not numbered my examples because I don't care. They stole my program from last year, so I'm just cutting and pasting from that. So what do I do? What's true about these? These two are what if cotan equals tan? If cotan equals tan, do you see that? It's like getting slower writing these. If cotan of an angle equals tan of another angle, what is true about those two angles then? They are equal to 90. They are complementary. Going back up to this may spur a brain cell of what we did back then. Not saying it rip, but spur, like get that area of your brain where we did this. Co-function was complementary relationships. Remember? When we did chapter 2, the co-function identities are the complementary ideas. What this means is these two angles are complementary to each other, right? If I put 30 here, then 90 minus 30 is 60. So what we did back in the day for this, instead of, what I used to do is change this to tan. Then I'd say tan of 90 minus parentheses theta minus 10. Uh-oh, we got a customer. All right, so what would be true then is this. We sped this up when it was a little bit more complicated to that complementary idea, and then we solved for that. Okay, so I'm done with that little section. That just pops up again to remind you of these identities. These I will never make you memorize, though. You should, but I don't think I have these in my little memorization section for the 5354 quiz. I do have these once that I do expect you through doing your homework that you can at least remember from doing your homework one time that these are what they are. Then after that, they'll be on a cheat sheet, okay? 5-1, page 200, I think I have the right page now, will never be on a cheat sheet. And you will always have to have those memorized. Now, what do I have left? It's like an endurance test. Three examples left. You're going to need me for this. So go ahead and take a minute to take that down. As you were writing this down, I gave away too much. Like this was written here. Winning. And that's the stuff that you do have to remember. This is a really... all right. There's no purpose for these questions. I'll just throw it out there right now. The only purpose is to exercise your formulas and then get used to knowing what they are. And then that's why if you do your homework appropriately and do it, you should be able to at least have some idea what these formulas are once for me. I really feel that is the case. So what we need to focus on are the parts that matter, like this first one. I have to do this. My pen's writing slower and slower, by the way. So first thing I should write is, what is that? So what is the cosine of n plus t? What does the formula say it is? It's the cosine of, get it started, so what is it? Cosine of n, then what? Times cosine of t minus sine, sin, I hate when they use these letters, times sine t. And really what you have is 2/4 of what you need, which is actually the same as 1/2. You already have the cosine of n. What is it? 15 over 17. And if you put a cosine in front of this, you are telling me that you do not understand trig enough. You take the cosine of an angle measure. The result of that is a ratio of two sides. That is the ratio of two sides for whatever angle n is when you cosine it. And then what's the other thing that you know? Sine of t. And you can go ahead and insert that in here. And then once you do that and understand that, you probably will know what to do easily next. Which you should just real quick draw angle n and draw angle t. Now, it does say both n and t are in quadrant 4. So that's just testing, can you read? Not can you, will you? Because some of you just look at the numbers and try to get answers and don't read the fine print. So if I put n in quadrant 4, I know two things about n. What do I know? Well, that's what I gave you. That was too much. What do I know? But it's up there. What do I know? I know the x and r, or the adjacent side, and the hypotenuse. What is the missing side? As a matter of fact, this is a Pythagorean triple. What is it? It is 8. If you don't know that, that's fine. What you need to do off to the side is do 15 squared plus y squared equals r squared. It's not 8, by the way. It's negative 8. Okay? Then when you subtract, you get y squared equals 64, and then you root. Fumble. And then you get a negative 8 because it's... are you okay? Is the math bringing you down? All right, now, so what does that mean? This is n. Ah, here we go. Here we go. Watch where I touch. I almost touched that corner over there that screws up everything. This is angle n. So what do I know now? I know the sine of n. What's the sine of n? I don't know if anyone heard that. Now, this would be a no calculator section. Oh no, but what about 17 times 25? We'll see. You know, if maybe I'll give you that product out loud. If I made this a no calculator, I'd say, hey, by the way, 17 times 25. But you know, you can find it real quick. Not that way. I just made a bad writing there. 25 times 10 is what? 250. Then all you have to do is 25 times 7. What's 7 quarters? What's 7 quarters given to the lunch lady or lunch guy? 175. Adam. Right? Yeah, you could do the old grade school way, but I was doing it the quick way. And then that would be what, 425? There you go. Okay, then back to T. Draw T, because it's also in quadrant 4 from our given directions. And what do I know about T? I know the Y is 24, negative. 25, blank 24, 25. Blank 24, 25 is a Pythagorean triple. 7, or I'm not teaching the Pythagorean theorem anymore. X squared plus negative 24 squared, the negative being squared, of course, equals 25 squared. And then going from there. So the cosine of t is 7 over 25. 7 times 15 is 70, plus 35. 105. I just did it again. 7 times 10, 7 times 5. Helping you with your mental math. And then we found out this was 425 minus, because it's this it's the sum rule for cosine, which means minus is in between. But this is a negative times a negative, which is a positive. 8 times 20 is 160. 8 times 4 is 32. 160 plus 32 is 192 over 425. You're always going to get a common denominator here on these, so just be aware of that. Is it 87 negative? Is it? I'm actually better at multiplying than I am at like adding and subtracting. Be listed. And then what's quadrant 3? What's between quadrant? What makes you in quadrant 3? From pi to 3 pi over 2. So we are going back to things that we did not since chapter 3, at least having that knowledge. So that's what got disappeared with my highlighting from my old files. So it's the same question, and the reason I'm going to do tangent is because we do have that fractional problem. You know, with radicals, it's real bad. This is not so bad, but still people are terrible with fractions. I'm going to say it. Going to be rude. Let's do colors this time, where A will be red. So A is in quadrant 2. Is everyone okay out there? 4 and 5, why? We're not even listening, so I don't need you to chime in. And R is 5, right? So for angle A, we know Y and R. And we're being told it's in quadrant 2. That's just to see if you're reading. Because what does that make the X value? What kind of number? Negative. And what is it? Come on, this is one of the easiest. It's negative 3, 3, 4, 5. Okay, it's a 3, 4, 5 triple, so I should be able to do that. Then in green, we got negative 5 over 13. It's in quadrant 3. So here's B's real drawing, but here's its triangle. And then we got negative 5 for X and 13 for Y because that's what cosine is. X over R. What is Y? You guys don't know that triple? It's not 7? Okay, I better do that one off to the side. I don't know where I want to put that work there. So it's negative 5 squared. This is the last time I'm writing the Pythagorean theorem in this class. This is cat. Meow. 13 squared. This is 169. This is 25. Subtract 25, you get 144. What is it? 12. What kind of 12, though? Negative 12 because we're in quadrant 3. All right, so now, what's sine of A plus B? Let's get this done fast. Sine what? Sine what? A. Cosine B. Sine's the same. I like doing sine. Doesn't that make it feel better? Like, okay, sine. Oh, it's got to be sine B because I already had sine A. And then cosine A. I love writing it that way. Then it's easier for me to remember. You don't have to. Okay, that's fine. Don't. Okay, good. All right, so what's sine of A? 4 over 5. That was given, I think. And then I said I was going to do colors. What's the cosine of B? That was given. Weren't the first two given? Negative 5 over 13. So again, it's one of those where you had half of the question already given to you. You needed the completion of the triangle to get the other part. Plus, there. Oh, I did it. That was almost a disaster. Go away. Go away. It won't go. Okay, all right. Almost caused a total destruction of the notes in the video. Okay, what's sine of B? Oh, that's supposed to be green. Negative 12 over 13. Getting a little shaky. And then what's the cosine of A? Me, not you. What's the cosine of A? Negative 3 over 5. What's 5 times 13? Let's just pick a color. Let's go thick blue. What's 5 times 13? No time. It's 65. This is negative 20. And then this is 36, right? This is 16 over 65. Does it reduce? 16 is 2's go into it. 2 times 2 times 2 times 2. 65 is 5 times 13. So that's it. Now let's simplify this tan A plus B. Okay, so first of all, I'm not writing it as tan A, tan plus tan B. We're just going to go ahead and do tan A first. Tan of A, what's tan of A? Maybe we'll zoom in a little bit more. What's tan of A? Tan of A is negative 4 over 3 y over x, right? Now what's the sign up here? What's the sign up here? Same. What's the tan of B? What's the tan of B? I'm not going to the colors. It's too hard. Fine, I'll get the colors. What's the tan of B? It is positive 12 over 5. And now I'm done. 1 what? Minus, and then I'll stay red, negative 4/3, and then I'll go green just because, maybe. Winning 12 over 5. All right, before I do anything, I'm going to make sure I have this done because I'll show you the quick way to get this in good shape. Okay, so I'm going to rewrite negative 4/3. I thought I'd change colors, but that's fine. 12/5 over negative 4 times 12. But it's minus a negative, right? So what can we ultimately say down here? Plus This is 48 over what? 15, which I think might reduce, doesn't it? I should have I could have cross-canceled the 3. Let's just stick with it. I'm going to do it. Okay, now what can I multiply both top and bottom by? What should I multiply both top and bottom by? Not 3. Not 5. 15 was right. Because what this does is gets rid of all the little fractions, and this helps the majority of the people. This is what I'm going to do, and you're going to like it. How many times does 3 go into 15? 5. So 3 goes into 15 5 times. So 3, this becomes 5. What's 5 times negative 4? I said that wrong. 3 and 15 cross cancel with a 5 left over. 5 times negative 4 is 20. Negative. 5 goes into 15. And there's what left over? 3. 3 times 12 is 36. 15. Don't forget that part. And then this is just 48. And then guess what you got? Oh, I'm going to have to scare somebody. And this is 16 over 63. Hey, I have a question. Without doing anything, what's the cosine of A plus B? You have 5 seconds to answer. 4, 3. What's the cos? No, I want the answer right because you should be able to see it. 5, 4, 3, 2. What's the cos? Huh? Boom shakalaka! I should give that girl a sticker. I'm gonna. How did she get that? What letter does this represent for the angle A plus B, whatever it may be? That represents X. What does this represent for the angle? That's not what I want. Let me go back. Let me go back. For the angle A plus B, whatever it may be, what does that represent? Nope. R. What's cosine of an angle measure? X over R. So whatever A plus B is, it'd be dealing with those same ratios. By the way, when I add A plus B, what quadrant does it land in? Look at these answers. What quadrant does A plus B have to land in based off of these ratios that we got? 1, because they're all what? Positive. So just a couple things. You get a sticker. I don't know where I put them.